All right, I want to take a moment to go over some Google Sheets things that might help you as you're analyzing your data for your project. I am coming home from the longest bowling tournament I've ever experienced, so sorry if I'm a little bit out of it, but I think I'm going to be able to explain it well, and my dog's going to be really needy during this, so don't mind him if he makes an appearance. So first of all, if you have your data in your lab notebook, I recommend kind of converting that information into a Google Sheet. Similar to this, I'm kind of copying Jessica's idea here with like heart rate and participant numbers for a table. But yours obviously might look different based on your project. So first of all, I recommend making your titles or like labeling your columns basically with that first row of cells. So here I have like participant number, their heart rate while sitting, and I assumed I did this twice here, their heart rate while standing, again taken twice. And that's kind of like what I have in my notebook. One little tip I do have is if you are doing something where you have like a lot of participants, because human participants often are a pretty large number, if you start by labeling them 1, 2, 3, and then you highlight these 3 cells, this little blue dot comes up. If you click and drag that dot down, it's going to continue counting for you. So you have to kind of start with like 1, 2, 3, but then click and drag down, it'll do the rest for you. So that's often really nice. The other tip I have as you're setting up to table, first of all, ignore this convert to table thing. It's never gone well for me. You can also freeze the first row by right-clicking and then going down to, it should say view more row actions, and then selecting, sorry, it's hard to do this while recording, freeze up to row 1. What that's going to do is, you're probably going to have up to 50 participants or so. As you scroll, you'll be able to see your titles still. So that kind of just makes it easier to view as you're scrolling. So I do recommend that. If you're using Google Sheets to kind of format your table to paste into a document, I also recommend centering everything. So going where it says horizontal line to centered, and then also centering the text as well. That's just generally a good look. You can also, if you go to, I believe it is a format. Yep. If you go to format down to alternating colors, I gotta move this little menu bar. Sorry about that. Format alternating colors. You don't even need to have it like in color, but even just like this gray generally makes it really easy to read. So I do kind of recommend that. This part over here that I have, I would not include that in my table in my paper. This is just some math, some formulas I'm going to show you, but I do recommend that. My other recommendation is if you do have a really long table because you have a lot of participants or a lot of data, in your paper, you can do like a condensed table, like maybe you just do like 5 samples, basically, within your paper, so you don't have like this really long table in the center of your report. And then you can include the full table at the end after your references in something called the appendix. So the appendix is where we put things that aren't really relevant for our discussion stuff, particularly, but could be helpful for a reader. So like when your judges are like, oh, you only have 5 participants here, you can be like, oh, well, no, really, I had 50. Here's the full table. I just saved some space there in my paper. Okay, enough yapping about that. Let's say, like in my example here, you took 2 heart rates and you want to find an average for that. For me, I think it would make sense to insert a column on the right. And I'm going to insert a column, even though I don't really need to here on the right as well. And I'm going to call this average sitting heart rate. I should probably capitalize sitting just to be consistent. You can probably hear my dog in the background. He wants attention. And then average standing heart rate. Okay, which is a little big. I can make that column bigger just so the text isn't kind of overbearing. So if I want to find an average sitting heart rate for participant 1, I would type in equals, and then average, and then it's going to give me the suggestion, actually. And then I want to use the open parentheses, and these are the two averages that I want to select. So I can either do that by clicking and dragging, closing my parentheses and pressing enter. It's going to, again, suggest. Sometimes the suggestions are helpful, but I'm going to continue forward as if it didn't. The other thing you can do is you can type in the cell coordinates. So you could also do equals average, and then type in, for example, B3 colon B4. Not B4, C3. Sorry, I'm going up and down rather than left to right. And then close. The other thing you do, you only have to type this in once. I didn't have to type this in for the second one because, again, if I click the cell, grab that little blue dot and drag down, boom, it's going to automatically do it. So if you look here, it's done it for B4C4, B5C5, B6C6, etc., etc. So again, I can do that over here. Equals average. I'll go ahead and click the suggestion since it is in fact what I want. And then I'm going to click and drag down. Great. So a lot of you did do multiple trials with people and decide that you wanted to find an average. So that's a quick way to do that so you don't have to just keep typing in your calculator and then typing into your Google Sheet. I'm going to scroll over here a little bit. So let's say I want to find the overall mean of the heart rate while people were sitting. It'd be kind of very similar. Equals average. And then rather than doing two cells left to right, I can go to my average sitting heart rate, click and drag down there, close parentheses, and press enter. Boom, does it for me. This is not the suggestion that I want, so do not follow that. It's going to continue to try to find averages there. If you have a lot, rather than click and dragging, like if you have like to keep scrolling down, you could also do D2 through D1000 because there's no way you have 1,000, right? And that's going to include all those cells. If the cell is empty, it doesn't count as 0. It just doesn't calculate it. If you don't want to show all these decimals, you can pop up here and move the decimal. You know, maybe you just want a whole number. That's fine. You can do the same thing for the standing mean. So equals average. And I would do G2 through G1000. Boom. Cool. If you were interested in finding like the maximum heart rate sitting and standing among your group, you could do equals max and then through your data set. So that would be for, I'm just going to do it for sitting. I'm not going to do it for both. So for sitting, I would do D2 through D1000. Boom. And if I wanted to know like the minimum sitting heart rate, same kind of deal, equals min, and then D2 through D1000. Boom. So that gives me kind of the highest and lowest of each, if that's something that you're interested in including. If you want to know the median, you don't have to organize them from low to high or anything. You would do equals median. And then I'm again going to stick with sitting, D2 through D1000. Boom. Median was about 96.5. The last thing, some of you may be, this might be a little bit, I don't want to say challenging, but like adventurous for some people to try to do a t-test. So this is to basically help decide if there is a difference between your groups. So for example, the mean for sitting was 97 beats per minute. The mean for standing was basically 101 beats per minute. That is a difference. 97 is not equal to 101. But the next question we ask ourselves as scientists is it a significant difference? Because some things can be due to random chance. I'm going to let my dog out real quick. Don't mind me. Thank you. Next question is it significant? So one way we do this is through a t-test. And I'm just going to give you a quick crash course. You can use a t-test calculator online. Totally worth it. You can also do it on Google Sheets. So to do this, it's again equals, and then we have t-test, open colon. The two data sets that I'm comparing is my average sitting heart rate to my average standing heart rate. So my first thing I'm going to do is select D2 through D10, comma. The next group I want to compare is my average standing heart rate. So that's G2 through G10 there, comma. And then the next two inputs are kind of weird. So after, I would say most of you would do a two-tail distribution. Basically, one tail just tests one direction, low or high. Two-tail does both. So I've always done a two-tail test, so I'm going to do comma 2 for two-tail. And then my last one, this is where you would ask Ms. Ollier for kind of some advice. But here I would do, or my sample, dog is back. Good boy. My group is what's called a paired test. So it's the same people tested twice, sitting and standing. So that would use the number 1. If it's not the same group, if you have like males versus females, I believe you would put in 2 to be unpaired. I believe that is the code. But in this case, it's the same person sitting, heart rate, and standing. So I would do a 1. And then I'm going to press enter. And it's going to give me a number. This one is 0, which is a good sign. I'm going to add some decimals. Yeah, it's 0. Typically for a t-test, I kind of wish I did numbers that weren't so significant. Nah, I won't fudge with my numbers. But basically, if you get a number, I'm just going to put this. If you get a number that is less than 0.05, as 0 is, that tells you that your difference between your two groups is in fact significant. You are 95% confident that this difference is not due to random chance. If you get a value that is less than, or sorry, that is more than 0.05, you cannot be confident that this is not due to chance. So there's a chance it's due to chance. So yeah, that's kind of like the crash course that I have for you for a t-test. If you have unequal sample sizes, like group 1 and group 2 aren't the same because you have unpaired, there's a different kind of t-test you can do. For the one on Google Sheets, you're going to want to have equal sample sizes. Okay, so that is the stats kind of table I have for you. Next, I'm going to go through some examples of graphs. This should be a lot quicker. Most of you will likely have a bar graph, which you are going to use for if you have something called categorical data. So if both of your values aren't numbers, you're going to probably use a bar graph. So in this case, like I have the sitting heart rate and the standing heart rate, and then I have a number. I only have one number. The other thing is categorical, sitting and standing. So the other thing I'm going to do, I made a different sheet for my graph. You can always kind of copy and paste data, but you can go equals and then go back to your stats table. And I think that was sitting. I should have checked better. Equals. No, that's not what I wanted. Sorry. One more time. So that is in fact saying equals. Table stats. Clicking my cell and pressing enter. Boom, it'll copy it over. Same thing for standing. I can do equals, go back to my data table I have. I don't know why it keeps doing that. That's silly. I'm just going to delete that part. Equals, standing mean, boom, enter. So that's one way that you can carry over data, FYI. I'm going to get rid of these decimal places because I don't want them. Okay, so now I have my data in there. I can highlight both things. When you're doing a bar graph, I recommend doing your qualitative data here, so like your condition or trial number, whatever, and then your actual like measured quantitative data in column B. But you would basically highlight your stuff, there we go, go to insert, and then do chart. Sometimes it predicts the chart you want, sometimes it doesn't. Okay, in this case it did. Perfect. And it's going to give you a little chart. I always double check to make sure things line up because I've had issues with Google Sheets in the past where things aren't lining up. But sitting is about 97. Standing is about 101. Perfect. And this is just kind of a table of averages. If you want to edit any of the titles, you could go to customize. So for example, I might want to include like my heart rate unit is beats per minutes. So I could go to customize and then chart and axis titles, switch to the vertical axis title, and then add heart rate beats per minute for my unit, and it will edit it there. You can also edit the color. Feel free. Usually it's pretty good with that. What else? Some of you will have like red bars and stuff like that. So like if I were doing each individual person would have a different color. Totally valid. There's ways to do that as well. Happy to show you that in class. You can do things like add error bars, but I do recommend like identifying what that means. So standard deviation I think is the best kind of for my error bars. But you don't have to include them. I would not include them unless you know how to explain what your error bar is telling you about your data, like what it's depicting, okay? Don't do it just because it looks fancy. Yeah, I think that's all I really have. If you have the option to make it 3D, don't do that. I know that's somewhere on here. Don't do it. It's misleading, essentially. So always just keep your charts as simple as possible. And that's how we do a bar graph. Like I said, if you need like multiple color bars, happy to help with that. That might be more of a in-person kind of question if Google Sheets isn't giving you the graphs that you want it to give you. Okay. Next, I'm going to move on to do a line graph. I don't think many of you will actually have line graphs. This is where you're going to have two quantitative data points. So for example, we do a lab in AP where we're measuring the change in concentration as a reaction proceeds, so versus time. So a few of you might have line graphs, but I think most of you are going to have bar graphs. So same kind of deal. You would want your x-axis, which is your independent variable, on column A, your y-axis in column B, which is your dependent variable. So you can highlight your data, insert, chart. Let's see if it gives me the chart I want. It actually doesn't. I know you're thinking that's a line. Instead of just a straightforward line, I actually recommend a scatter plot because here it looks like you have infinite data, right? That you've measured every single second and millisecond, microsecond through 210 seconds. That's not true. We didn't do that. We only measured at 30-second intervals. So instead of a line chart, I'm going to do a scatter plot. Okay, and it still gives the same data as a line chart, but it's again not misleading you into thinking that you've measured every single millisecond. So recommend a scatter chart. You'll notice here that my range is all up here. Typically we like to use the full space. So if you get something where your dots are clustered together, it does help under customize. Gotta move my screen a lot. Where is it? Horizontal axis? Yeah. Under horizontal axis, you can kind of change the range. So since my smallest range, rather than doing 0.00, I'm going to do 0.02. And then my maximum value, I'm going to put in my maximum, which is 0.025. And if I press enter, it should kind of work. That's not what I want. Again, sometimes Google Sheets doesn't do what I want. That's not what I want. It did it earlier when I tried. Am I on my x-axis? No, I'm on my horizontal. That's what I want, horizontal. Reverse axis order, that's not what I want. No, don't like that. I messed something up here. I'm going to press undo. I practiced all this before I press record, if you could believe it. Okay, here we go. Concentration versus time. Okay. Now where are my data points? All right, this is the point where I would delete the chart and try again. I know it sounds like Twitter talk, but sometimes Google Sheets is just a little silly. Okay, insert. Chart. Don't want a line chart. I would like a scatter plot. Beautiful. Customize. Vertical axis. Minimum 0.02. Maximum is already at 0.025, so I'm not even going to address that. There we go. So that kind of fixes the data a little bit. I could probably go even further. My smallest point is 0.0232, so I could do 230. There we go, and that fills out my whole chart. I'm telling you, Google Sheets is wild. So yeah, that's how you adjust the axis. If it's like all clumped together, feel free to make those adjustments, no problem. Okay, thank you for bearing with me. Final chart type you might see is a pie chart. Little disclaimer, every time I've tried to put a pie chart in any of my research papers since high school, all of my teachers, professors have said, don't use a pie chart, use a bar graph. And it has to do with like accessibility and color contrast. When you print out your pie chart, it can be hard, especially for the visually impaired, to interpret a pie chart. I think at the high school level, it's fine. I was never told at the high school level it wasn't fine. So if your data fits in with a pie chart, feel free to try it out. You might just also want to make a bar graph, and that would be, again, something that you include in your appendix. If a judge comes up and they're like, I don't know, the pie chart is the best way to show your data. You could be prepared, and you could be like, I was actually kind of between a pie chart and a bar graph, so in my appendix here I do have a bar graph. So I can absolutely change that in future presentations, okay? And then they can judge you higher, right? Life hack. Anyhow, pie chart. Let's go. This is a simple yes/no poll. Don't know what the question was. I made it up. Once again, this one's a little bit different. Like a bar graph, it will be categorical data and your quantitative data. Again, here we got yes and no. Qualitative data is column A, quantitative column B. We highlight, we insert, and I usually insert my percents as decimals. It should work if you type in your numbers as percents as well. So insert, chart. Ooh, look at that. Boom, wanted me to do a bar graph. See, it happens all the time. But no problem for us. We know how to change it. We go to chart type and we click pie graph. And once again, I like to check to make sure that Google Sheets did not make a mistake. So yes is 45%. Yep. No is 50%. Beautiful. What is this chart missing? A title. Good job. So under customize, I can add a title. That never changes. So under customize, chart and axis titles, chart title. What should our chart title be? I don't know. Where would we vote no for, Tucker? What do you think? I don't know. Should we wear uniforms? Maybe you polled the children, okay? And they were like, no, pretty split, okay? That's my dog in his bone, sorry. Yeah, that's how you add a title. Easy peasy. Yeah, and you can do things to change the color. With pie charts, I definitely recommend keeping high contrast. So like this red, blue is very high contrast. You don't want to do really close together colors. Like maybe I did this purple and this purple, not high contrast, okay? So keep it high contrast. You do a light color, do like a complementary dark color where there's like this clear difference. Even that's not great, honestly. So yeah, I would just stick to the high contrast red and blue that it defaults to. All right, I think that gives you a good crash course to get started. As always, if your question wasn't answered or you're having issues, no harm in asking. As you saw me struggling with the line graph, Google Sheets is kind of different every time you use it, even though it's not, but sometimes it is. Okay, I'm going to end this video because it's probably already way too long. Thanks for hanging in there. Happy Science Fair. We're almost to the end. Data analysis. Let's go. Come here, Tucker. Do you want to hop on up? Come here. Come say hi. Come on. Come on. There we go. Say, Tucker's so happy that you guys are doing Science Fair. All right. Bye.